So let's take a look at the three programs that you'll be writing today as part of the lab. In the first program, we're just going to be using a single servo motor, and we're going to be controlling it sort of abruptly. We'll be telling it exactly where to go, and then we're going to give it time to get there. But in this case, what we're going to find is that in order to control these servo motors, we're going to include the servo.h library. Now, the servo.h library does most of the work for us. I think what you'll find is that the programs you're going to write for today's lab are going to be simpler than the programs in some of the other labs. And this is sort of one of the reasons why the Arduino is so nice. So one of the reasons why the servo motors are so nice is that the code is not hard to write. So we're going to need to include this library, and then once we've done that, we've identified that there's a thing called a servo, and we're going to quote unquote instantiate a servo. In other words, we're going to say there exists a servo, and we're going to call it servo 1. And this is going to be the only servo motor in this program, and the name for it is going to be servo 1. This name is important because now we can reference that servo to tell it things like attach to a certain pin, write to a certain value, and so forth. Here you can see that in setup, there's only one thing we need to do, and that is we need to attach it. We need to attach servo 1 to pin 9. And what attach does is it says, anytime that I issue a command in the future about servo 1, I want you to go ahead and send that signal out over pin number 9, because I have physically connected pin 9 to the control line of servo number 1. Down here in loop, you can see that I say servo1.write 0. Well, that says I want you to go to 0 degrees. That's going to be all the way counterclockwise, sort of pointing to the left at about 9 o'clock on the clock. Then I'm going to wait a second. Now, see, I don't really know how long it takes for the servo motor to get to this destination, but I know that it's going to be less than a second. So I'm going to go ahead and give it a second to get there. Then I'm going to say, go ahead and turn it to 90 degrees. That is to say, pointing straight up at about 12 o'clock on the clock. Again, I'm going to wait a second, probably too conservative, but I'm certain that it's going to get there by 1 second. Then go ahead and turn fully clockwise. That'll be 180 degrees or about 3 o'clock on the clock. Wait a second. Then go back to straight up, and then wait a second. And then because of the nature of the loop, once it gets back to that point, then it's going to go back to 0, pointing straight to the left. Wait a second, straight up, to the right, straight up, to the left, straight up, to the right, straight up, to the left, and so forth. So the loop here is going to give us the opportunity to do the sort of complex interactions that we need them to do. Now, that was abrupt transitions, but we can also do smooth transitions. And in this lab 12B, you'll find that this block of the code is really identical to the previous program. It's just that now there's going to be some new stuff going on in the loop. So in loop, we're going to define this integer position. And so this position is going to keep track of where the servo motor is. And this is going to be inside of a for loop. Now remember how a for loop works. You have the initialization, you have the sort of continuation condition, and then the update. So in other words, this is what happens at the beginning. We're going to set position to be equal to 0, pointing straight to the left. I'm always going to check to see, is position less than 180? If so, go ahead and continue on and do the loop one more time. And then each time through the loop, increment position by 2. So in other words, it'll be 0 degrees, and it'll be 2 degrees, and it'll be 4 degrees, and 6 degrees, and so forth. I'm going to go ahead and write that position out to servo number 1. Then I'm going to delay by 20 milliseconds. So that 20 millisecond delay is more than enough time to move the 2 degrees that we need to move. We can in fact adjust this. If I wanted the servo motor to move more quickly, I could take a bigger step. I could go 4 degrees or 3 degrees instead of 2. Or I could adjust the delay. If I wanted it to go more slowly, for example, I could make the delay be 50 milliseconds. Or I can make it be 40 milliseconds, then it would go twice as slowly or half as fast. Once I go all the way from left, I'll rotate around to right, then I'm going to go ahead and do the opposite. I'm going to start at the right, I'm going to rotate back to the left. And I'm going to have to decrement the angle rather than incrementing the angle as we did before. But everything else is identical about this loop as compared to the previous loop. So we've seen how to control it one servo motor with both abrupt transitions and with smooth transitions. Let's look a little bit about how we might control 2 servo motors at the same time. We're still going to include the servo.h library. I'm still going to create a servo motor and call it servo 1, but now I have another servo motor called servo 2. And rather than just attaching servo 1 to pin 9, now I also have to attach servo motor 2 to pin 10. Really not much new here. It's just that now we have two servo motors and we have to attach both of them. I'm going to go into the loop and I'm going to go ahead and send both of them to 0 degrees. So servo 1 dot right of 0 and servo 2 dot right of 0. I'm going to tell them both to point straight to the left, and I'm going to wait a second. Then I'm going to say point straight ahead, point straight up at 12 o'clock, both of them, and then wait a second. Then point straight to the right, and both of them are going to point straight to the right, and I'm going to wait a second. And then I'm going to say send only servo 1 back to 0, because everything that happened up here, this was all sort of happening all sort of in synchronization. Both of the servo motors were doing exactly the same thing, but now I'm going to mirror image what the two servo motors are doing to show that they don't have to have the same value. So I'm going to loop position to be from 0 up to 180. And taking in steps of 2 with the 20 millisecond delay, servo 1 dot right position, that's just like the previous program that we saw. But servo 2 dot right is going to get 180 minus position. So when servo 1 is pointing straight to the left, servo 2 will be pointing straight to the right. And as servo 1 is moving clockwise, servo 2 is going to be moving counterclockwise. Once we've reached our destination, we're going to go ahead and sweep in the opposite direction. And in the same way as before, servo 1 is going to be going from 180 degrees down to 0 degrees in steps of -2. But servo 2 is again going to have the mirror image. It's going to be 180 degrees minus the position. So as servo 1 is sweeping counterclockwise, servo 2 is going to be going back clockwise. And with each step, we're going to have a 20 millisecond delay. So what we can see is that the two servo motors can be totally synced up. They can be synchronized, going in the exact same orientation. They can be mirror images of each other. Heck, they can even be completely independent of each other. And we have these options. When we're working with more than one servo motor, we can end up with some pretty complex interactions. As a matter of fact, that's the last thing you're going to need to do in today's lab, is to implement this 5-step sort of robotic gait. If you assume that one of the gait is just a fancy word for walking style, by the way, this is if we're going to have a robot where the hip is represented by one servo motor and the knee is represented by another servo motor, we're going to have a 5-step process that's going to allow you to show how that leg is going to move forward. Of course, in order to have a 2-legged robot, we would have to have 2 legs. We're only implementing 1 leg. You'd probably also need an ankle, so you'd probably need 3 servo motors for each robot's leg. You'd have 2 legs, so that'd be a total of 6 servo motors. The good news is the Arduino would be more than capable of delivering the signals necessary to control all 6 of those motors. It's just that for now, we're going to limit ourselves to just the hip and the knee of one of the 2 legs.